remind you about the academic integrity policy for this course. In particular, labs, we require collaboration there. We randomly pair you up, and we're discussing possible changes to that. Hacks, we have open collaboration. You can always work alone if you want, but you are allowed to work with as many people, other people as you want, pairs, triples, an entire group if you want to, as long as you put everybody's name on in the header as authors. However, assignments, your first one is due this Friday at midnight. Remember that there's closed collaboration on that. That means that there is no collaboration, direct collaboration with another student in this class or outside the class. That doesn't mean that you're barred from asking questions, high-level questions to each other, and certainly to the learning assistants, graduate teaching assistants, and myself, and on Piazza. Just do not post code on Piazza for the assignments. So keep that in mind, and make sure that you're reading the rest of the document, acceptable code use, etc. But I just wanted to show you, to dissuade anybody from, if you do end up waiting to the last minute and you feel like, oh man, I'm under pressure here, and you are tempted to cheat or tempted to pull that piece of code from somebody else or give that piece of code to somebody else, I just want to show you what the tool that we use. This is not used in this class. It's called MOS. It's called Measure of Software Similarity. These people did not cheat. They were allowed to collaborate in this particular course that this sample is taken from. But you can see how easy it is to catch people, right? I'll just go ahead and zoom in over here. All I have to do is hit one button and a report comes back for every pair in the class of this person matches 90% with this person, or this person matches 99% with this person. And if you open it up, you'll find out that they were actually partners on that, and that's why they're matching. All the way down to, not 0%, but 29% match, 25% match. They probably did not collaborate. This is how ridiculously easy it is to catch people on plagiarism issues with respect to code. You cannot hide from this tool by simply changing variable names or changing comments or changing white space around. It ignores all of that stuff. It's rather sophisticated. It builds an abstract syntax tree. It's basically half a compiler and finds structural similarities between two pieces of code. Now, this is not a smoking gun. This is a tool we use to find the people who probably collaborated with each other at some level. And you'll see here, I collaborated with this person while I just copied their code in order to test it or something like that. Then what we do is we use this tool and then we take a second look, right? That entire red spot is basically copied code, right? Which makes sense because they turned in the exact same file because they collaborated together, which they were allowed to do. I want to reemphasize that. But in this course, for assignments, you have a closed collaboration policy on it. All code has to be your own. Now again, it doesn't mean that you can't ask questions of each other. For example, there were a couple of questions just at the beginning here and during my office hours of, well, how do I do this on GitHub? How do I do that on GitHub? Yes, go ahead and help each other on that. If you're having trouble troubleshooting your Samba connection, your Z drive connection, go ahead and talk to other people about that. We do want that kind of collaboration. But the assignments are there to prove that you haven't just been relying on other people to do everything throughout the entire lab and the hacks. Now is your time to stand on your own and show what you've learned, basically. Okay? All right. Questions? No? All right. Then, to continue and conclude, today is kind of a miscellaneous wrap-up because Monday was taken away from us for Labor Day. We started on conditionals, if-else-if statements, and you've been using those on lab yesterday, and you'll be using them in your assignments, of course. We went through basic numerical comparisons, the negation operator, and complex logical operators, the logical and the logical or. Right? Then we finished up with a few pitfalls to avoid and short-circuiting. What I want to do is I want to write a really quick program here as an example. Right? And I'll go ahead and copy over the exercise here. Let's write a program that reads in a decibel level from the user and gives the user a description of the sound level according to the following criteria here. You can't have negative decibels. Decibel is on a logarithmic scale. There's no such thing as a negative decibel. There's a negative amplitude where if you've got noise canceling headphones, it sends out a negative wave to cancel out a sound wave from somewhere else. But the decibels on both of those waves are still positive, or non-negative at least. 61 to 70 is conversational. 71 to 110 is loud. 111 to 194 is dangerous. And anything above 194, I don't know. We'll find out. All right? So what I'm going to do is I'm going to go ahead and open up, say, REPL. And let me bring it over here. All right. Let me go ahead and get rid of that, get rid of that. All right. Int main, int argc char argv. All right. And increase the size so that you can see it. Good enough. All right. Let's go ahead and write this program. So we're going to prompt the user to enter an input decibel level. So to prompt, I need printf. Please enter a decibel rating, or whatever it's called. Right? Now, how do I read in a decibel level? Scanf, right? Printf is for printing. Scanf is for scanning input, output and input respectively. So I'm going to want a placeholder, some kind of placeholder, and a variable to be read in. Well, if I need a variable, I should probably be declaring that up here. What should I call this variable? Decibel. Would D be a proper variable name? Just regular old D? No, it doesn't describe what it is. That's bad style. All right, so decibel. Make sure that you spell it correctly. I believe that that's spelled correctly. What type should it be? It could be a double because you can support decibel levels of 110.5 decibels, right? And it is on a logarithmic scale, so it doesn't scale linearly. It goes up like this. So you have a very good argument for allowing fractional values. For now, I want to keep it simple because apparently over here I was only considering whole values. What happens at 60.5? Is it quiet or is it conversational? I don't know. That's not part of the, this is a kind of a specification. If it's not part of the specification, don't jump to conclusions. Don't make assumptions. In a real-world situation where you've got a specification for a system or a piece of software, and you don't, and you've got this one case where you don't know what should happen, what rules should apply, that's when you go back to the stakeholder or the client or whatever, whoever you're working with, and you ask them to clarify. Well, what happens at decibel level 60.5, right? Do you want that to be quiet or do you want that to be conversational? For now, I'm just going. I don't have a client. I don't have a stakeholder to go and ask. So I'm going to leave. I'm not going to make an assumption, and I'm just going to assume that they meant that they only wanted to support whole decibel levels. So I'm going to go make it an integer. If I make the design decision to make it an integer, what placeholder do I need? %d for integer, a digit decimal, right? Decibel. Right? Is that correct? Nope. What am I forgetting? Ampersand. Good. All right. Okay. So I've prompted for input. I've read the input. Now I need to make a decision here. Is the value stored in that input quiet, conversational, loud, or dangerous? So let's go ahead and take care of that first one first. If decibel is greater than 0, or I guess it was greater than or equal to 0, right? Greater than or equal to 0, and decibel is less than or equal to 60, then we'll go ahead and print that it was quiet. Right. There we go. All right. That takes care of the first case there. 0 to 60 is quiet. 61 to 70 is conversational. So here's my first attempt. if decibel is greater than or equal to 60, and decibel is less than or equal to 70, printf conversational. Right. Is that correct? No. There are a couple of errors here, and there are a couple of bad coding style as well. What's one error right now? What happens at 60? What if it reads in 60? Let me go ahead and do that. Let's go ahead and run it. And please enter a decibel rating, 60. What's it going to print out? Predict. Quiet. And conversational. Why? Less than or equal to 60, greater than or equal to 60. So where was my mistake? Right here. To conform to this specification over here, I should look at 61, so greater than or equal to 61. Or, alternatively, if I wanted to be consistent about the numbers, strictly greater than 60. Right? Now, that's going to fix the bug, but let's think about this thing. Can something be quiet and conversational at the same time, according to these specifications? No. What did we call that? This happens or this happens, but not both. That's mutually exclusive, exactly. If we want to make it mutually exclusive, instead of having two separate if statements, what should we be doing to combine them so that those two conditions are mutually exclusive? An else if. Right? Else if. There we go. All right. And now let's go ahead and test it while we're going here. What should I test so far? Well, we should test 60 again, see if we get that same bug. Nope, it's quiet. Run it again. What else would be a reasonable test at this point? Something in the middle of a range, 30. Probably also want to test the edge cases, the things that happen at the edges of normal operating procedures, or the corner cases. There's a slight difference between those two, but don't worry about it. 0 should be quiet. What if I ran it for, I don't know, -10? What should happen here? What do you think? It should be an error, right? But nothing happens. Why? Walk through this program here. Is -10 greater than or equal to 60 and less than or equal to, or greater than or equal to 0 and less than or equal to 60? No. So this doesn't happen. They're mutually exclusive, so we provide this. Is it strictly greater than 60 and less than or equal to 70? No. So this does not happen. So what happens? Nothing. Just as we would expect. So let's go ahead and add a catch-all condition at the end. Else, printf, invalid decibel value. Right, there we go. And now when I run this, -10, sure. Oops, that's 10. I forgot the negative sign, -10. There, invalid decibel value. Okay. We still have loud and dangerous to take care of. So let me go ahead and commit a big faux pas, a big cardinal sin in coding. Copy, pasta. Right? Copy, paste. Copy, paste, copy, paste. That's called, we use a slang copy pasta for that. I think it's entered the more general internet lexicon now, but it comes from coding. Copy pasta leads to spaghetti code. What does spaghetti look like? A bunch of noodles all twisted together, disorganized. Try to find one end of one noodle and follow it to the other end, and you can't do it without taking out all the spaghetti and then reorganizing it, right? You don't want spaghetti code. You don't want disorganized, hard to follow, hard to maintain, hard to read code. One way that you get spaghetti code is by doing this, copy pasta. Right? There's a question, yeah. Hold that thought. I know what you're thinking. Hold that thought, and we'll come back to it. All right. So, the copy pasta. I need to change it though, right? It was greater than 70, right? And let me get rid of that. Greater than 70, and then what was the other one? 110. Right, there we go. Oops. 110. There we go. And 110, 194. So this would be 110 and 94. 194. And it was conversational, loud, and dangerous. Right? Now you might have, your keen eyes might have seen a mistake there. Right? That mistake was compounded because, again, I was doing copy pasta. Before you identify that mistake and give everybody spoilers, let's go ahead and try it out. It runs. Right? It means it compiles and it runs. There's no mistake, right? Let's go ahead and try 100 or let's go ahead and try 90. 90 should be what? Loud. Right? Invalid. What's wrong? Now go ahead and go with the spoilers. Yeah. Exactly. Well, not subtracted from the value, but this is not a syntax error. But it's also not a left arrow, right? The way that C is interpreting this is, and decibel is less than negative 110. Remember, white space doesn't matter, right? So I've hidden the fact, I screwed up by mistyping one place, but it's not a syntax error. I compounded that error by doing copy pasta. I copy pasted from one to the other. Now I've got two errors. So even if my eagle eye found out, oh yeah, well that's wrong, I should go ahead and fix that. That error is still down there because I did copy pasta. And so who knows how many times you might repeat an error by doing copy paste. Right? Avoid that. Bad practice. Okay? Let's go ahead and run this again for 90. Well, now it's loud. Let's go ahead and run this again for 120. All right, dangerous. I don't know, what will the decibel level be in Memorial Stadium this Saturday? Nobody's ever been to Memorial Stadium? They have a decibel meter there, right? What does it usually get up to? What? Oh, it's okay, good. Yes, it'll be 250 decibels, and everybody will be deaf. There, now it's an invalid decibel level. All right. So, well, we could add another category there, Husker game or something. All right. So there was, I think somebody was trying to point out another simplification earlier. Go ahead and point that out now. All right, there you go. Less than or equal to. I'm going to take your idea here. I'm going to focus on the second condition instead for a second. As you observed, we could probably simplify this highlighted statement here, right? If we got to this point in the code, what do we know? We know that the first condition would not have executed because they're all mutually exclusive, right? And so we know that decibel level is at least 0. And that it is, one case is that it's negative, but we know that it's at least 60, or it's at least 61, right? So we don't need to make that first condition there. The decibel level is strictly greater than 60, because that's already taken care of by the first condition up there. I can simplify this and take off that first condition, right? And this has the exact same logic because of the fall through. That the way that if conditions work is that they go top to bottom, and the first one that evaluates to true is the first and only one that executes. So if you've got more general logic or more specific logic up here and it fails that logic to move on to the next condition, then you can assume this logic up here. You can assume that it's greater than 0, for example. Right? With that idea, I'm going to separate the two invalid ranges, the negatives and the things that are greater than 195 decibels and greater. And the way that I'm going to do that is I'm going to add one more condition up here. If the decibel is less than 0, then I'll go ahead and do something else. Printf cannot have negative decibels. Right? So a different message, else. And now this is going to allow me to simplify what you were pointing out to begin with, that I don't need to check this. Right? If it's negative, then it's taken care of by this statement here. And then don't forget your if. Okay? If it's negative, it's taken care of by this statement. Otherwise, I can simplify it to this. Otherwise, I can simplify it to this. I can simplify this. Right? And that's yet another acronym that you can learn, and it's just a general acronym, KISS, KISS, which is keep it simple, stupid. If you can get away with fewer lines of code, fewer conditions of code, then you do it because it's simpler, it's easier to understand, it's easier to comprehend, and therefore it's more maintainable. Right? Yeah.
Is there a downside to using all those statements, else ifs?
They no longer become mutually exclusive, and you saw that manifest itself as a bug, right? That it said both quiet and conversational at the same time. There's also an argument to be made that it's more efficient this way, because if you've got 10 conditions and you check the first one, second one, third one is true, this executes, it skips checking all of these because it's all mutually exclusive, right? So why would you go down the list and yeah, no, 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 yes, no, 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 right? Don't waste cycles, right, doing that. It's also cleaner code, right? So lots of arguments against it. Right? Let's see if this still works. Oops, something's wrong. Where are we? Oh, forgot my semicolon. There we go. I don't know, 60, let's just spot check this, 200, invalid decibel level. And now I should get a different error message, cannot have negative decibels. These two ranges are both considered errant, right? You cannot have decibel levels that are negative, and anything that's 195 and greater is undefined. So you might want to have two different messages. You might want to treat those as two fundamentally different error messages, right? And we'll look at that more closely when we re-examine error handling. Right? All right, that's a pretty good program. It's all complete. What I want to do now is I want to switch modes, and I want to describe how we might be able to do this with what are called command line arguments instead. Let me go ahead and copy paste this. All right. Well, here, I'll go ahead and do it over. Let me go back to the notes here. So that was our exercise, and we'll come back to this exercise in a moment here with non-interactive input. So the program that we just wrote was interactive, right? And the programs that you're writing for your first homework are also interactive. We're expecting you to prompt and then read, prompt and then read. But most programs are not like that. Most programs are non-interactive, right? Non-interactive in that they're not expecting a human being to be sitting there at the keyboard, mashing the keyboard, giving the computer input. The whole reason that we write programs is to automate tasks so that we don't have to do the mundane things that we don't want to do. It would be completely against the point of writing programs if all programs were interactive, that we had to sit there at a terminal and type. Now, from a consumer point of view, everything is interactive, right? Because it's intended for a consumer to interact with it. But the vast majority of software that runs the world is not interactive. You start it and it's automated. It automates processes and it works alone. One program talks to another program. That program talks to another program, and it's all and there's no human in that chain at all, right? So one way of getting non-interactive input is through what are called command line arguments. Through command line arguments, or CLAs for short, you can provide input to a program when it starts. Right? So, for example, suppose that we have suppose our program has been compiled into an executable called a.out, which is the default and which is what you've been using so far. Then what you can do, you can provide command line, or I'll shorten it now, CLAs, from the command line, who would have thought, by using the following. So when you run a.out, normally you run it like this, right? You can provide command line arguments immediately after that. You can provide, say, 10, 20, 3.5, or hello, right? In general, each is separated by a space, or any number of white space if you want. The above example actually has 5 arguments, right? Do you see them all? 10, 20, 3.5, and hello. There's 4 of them. The 5th one is always the executable file name. Or the first, I should say, the 5th one in this case is the executable file name. In general, the first one is always going to be the executable file name. The first argument is always the executable file name, because you don't necessarily have to compile to a.out. You can move that file, you can rename that file to my awesome program. You can rename it to decibel.exe or whatever you want. And the operating system provides that name as part of the command line arguments. So in a program, how do you access them? You can access the arguments in a program using the 2 things in the main that I told you we'd look at later, int argc and char ** argv. Right? The first one stands for argument C. What do you think C stands for, other than the programming language? You know why it's called C, by the way? Because they were working. Dennis Ritchie and Kernighan, the ones who came up with C, they had previously worked with a programming language called BPCL, I think it was, which of course is short for B. And so, well, what should we call our programming language? Well, we've been working with B, so let's call it C. That's why C++ is called C++, because it's just the next one, right? They're not too creative on names, all right? So in this case, though, it means something different. argc is for argument count. The first represents the number, the count of arguments. Right? So in this case, if I called a.out with those 4 arguments plus the executable file name, argc would have a value of 5. Right? The second, that is argv, is a vector of arguments. Right? The first argument is stored in argv sub 0. This is what's called an array, which we'll talk about in more detail later on. For now, though, you can access the first argument by using argv sub 0. It starts at 0. Everything in computer science starts at 0. And the reason, there's very good reasoning for it. It's because that's called an index, and it represents a memory offset from a memory location. So the first one is 0 bytes away, in other words, don't move anywhere, from this memory location. The second one is 1 times 4 bytes away, and that's where you'll start finding the second one. We'll get into that detail when we look at arrays and memory management later on. The second is at argv sub 1, etc. Right? So where would the third one be? argv sub 2, etc., etc. The first argument is always the executable file name. So at this point, I'm going to turn it back to the example that we've been working on here. Let me go ahead and increase the size here. Come on. I just want this size to increase. There we go. All right. Let's go ahead and go back to our example here. And what I'll do is I'll remove this interactive input. When I post these later tonight, I'll keep that in there just so that you can remember how we wrote the program originally. But what I'm going to do is I'm going to change it to non-interactive input. In other words, I'm going to expect one argument, actually, actually 2 arguments from the command line. In particular, a decibel value. Right? So that when I actually run this program, I'll have a dot out 120 instead of being prompted for a decimal or a decibel level, and I'll say 120. What I'm going to do is I'm going to run a dot out and then provide 120 at the command line, so that it doesn't have to prompt me for input and I have to sit there and type it out. Right? So the way that the first thing I want to do is I want to check to see did they actually give us a command line argument. I'm going to use an if statement, which is exactly what we've been looking at here. I want to check, are the number of command line arguments correct? Look before you leap. If they didn't provide me a command line argument as a decibel value, then I want to quit on them and say, wait, you got to give me the decibel value, otherwise it doesn't work. Right? So I'm going to check argc. That's the number of arguments that was provided, and I should expect 2 of them. So if it's equal, if the value stored in this variable is 2, they provided 1 command line argument as decibel values, but the first command line argument, remember, is always the executable file name, a.out. So I need to check to see that it's equal to 2. If it's not equal to 2, then I should say you didn't provide the command line argument and quit on them. So what do I need to check for? If it's not equal to 2, then I'll printf error provide a decibel level as a command line argument. Right. There we go. Now, how can I quit on them? I can exit a program, and that one there is just an error code. That we're exiting with an error code of 1. Or you could do like we've been doing with this, return 0. 0 is no error code, right? 0 it executed normally and exited the program with 0, no error, right? Otherwise, we're exiting here with with an error code of 1. You can have an error code of 2, an error code of 3, an error code of 42, and each one of those has a different meaning for your program, and then the people that are using your program can read your documentation and write their programs around your program to take care of those errors. Right? All right. Once I know that they have the correct number of command line arguments, I want to access the real first argument and treat it as my decibel value. Right? So decibel is equal to, where's the first command line argument? The first real one? Argvis of 1. 0, again, is the executable file name, a.out. A.out is not the decibel level. Right? So I'm going to try to run this, and it's going to complain. It's actually not even going to compile. Right? Well, it's not going to compile because they don't put in the standard library. I should have done that at the very beginning. Now it's not going to compile because it's complaining about, which line number is it complaining about, by the way? Learn to read your compiler errors. Line 16, column 11. Right? Warning, assignment from int to char makes an integer cast. So this is just a warning, apparently, but it's still going to cause an issue here. And so what are we doing on line 16? The thing on the left-hand side is a what? It's an integer. The thing on the right-hand side, that's a what? That's a character. It's actually technically a character pointer, which is a string, right? 1, 2, 0, the string 1, 2, 0, not the number 1, 2, 0, right? So what I need to do is I need to convert. You may need to convert a command line argument into a number. Right? So to do that, you can use one of 2 functions. A to I, what do you think that stands for? A to I. The I stands for integer. It stands for alpha numeric value to integer. Or, what if I wanted to convert it to a double? A to D would make sense because of the placeholder and everything else like that. Maybe, but A to F, right? That makes more sense because it's a floating point number. So this converts to a double. So obviously I want an integer here because that's my decimal that's the type of variable that my decimal is. So I'm going to surround this with a to I instead. Okay. So I'm going to give this. This is basically a function, and you've been using those so far quite a bit. Sine. You want the sine of x. You put x in parentheses there, and it returns a value of the sine of whatever is stored in that variable. I'm providing this variable here that's a command line argument, the first real command line argument, to a to I, and it's converting it and returning it as an integer. Right? Now, this is a good question here. How does REPL handle command line arguments? Hover input. There we go. No, that's standard input. Okay. At this point, REPL is going to fail me, so I'm going to go ahead and come over here to regular old command line stuff. Okay. Ugh. There we go. Cut and paste. There's the program. Now let's go ahead and compile it. Sound.c. All right, still no errors. That's great. But if I try to run it without providing command line arguments, I'm going to get that error message that we programmed in. Provide a decibel level as a command line argument. Right? If I provide a decibel level 120 as a command line argument, it's going to convert that, and then it's going to run the rest of the program just as before. That it's 120 is dangerous. Yeah, 120 is dangerous, right? Yeah, good. I could provide a different command line argument. Negative 10, it'll convert that. Cannot have negative decibel values. I can provide something 2,000, right? I can provide two command line arguments. 220, 120 to 220. What do you think is going to happen here? How many command line arguments have I provided in total? 3. What does my program say? If it's not equal to 2, provide an error message. So what would you expect? That error message. Now you can go back in and say, well, if there's at least 2 arguments, then use this one and ignore the rest, if that's how you want to design your program, and that's perfectly fine too. But you can use conditional statements to check the number of arguments. You can use a to I and a to f to convert those arguments, and now you don't have to do interactive input at all anymore. You're going to be doing this tomorrow in Hack 3. But on homework 1, make sure that you're using the interactive, I believe, where the prompt and read. Once you get past homework 1, then everything will be expected to be command line arguments. Yeah. That would be a.out. Yep. And if you rename that file, it would be something else. Just to show you, this is not going to be part of the program, but you can go printf. Argv sub 0 is equal to, what do you think the placeholder is to print a string? String s, all right? Argv sub 0. And I'll prove to you that that's what it's doing. Go ahead and run it again. There we go. Argv sub 0 is equal to ./a.out in this case. If I could move a.out into my awesome program, and now I can go my awesome program 120 instead, and of course now what will it print? My awesome program instead. That's always going to be the executable file name. So if you, in general, you're going to ignore it. Don't worry about working with argv sub 0. What's another potential issue when using this? What do you think will happen here? My awesome program, TEN 10 instead of 1010. Is that a number? That's three numbers if you look at it from the perspective of the ASCII text table, right? It's not something that can be parsed though. What's going to happen is that A to I is going to look at this and say, I'm going to be looking at numbers. Right? I'm going to be looking for numbers. Like it did before 1, 2, 0. The 1, 2, 0, okay, I'm done. 120, that's what that represents. But this one is ten. It's going to look at t and say, is that a number, a number character? Nope. So it's going to stop. What has it parsed so far? Nothing. What's the numerical value of nothing? 0. Right? So we would expect this to be, have a decimal value of 0, which is quiet. Right? And that's what's working there. If you want to do a more sophisticated error checking, then we need a little bit more, the basis for doing that, and we'll look at that later on. Right? Don't worry about that stuff, though. We will always give you well-formatted input. We will never say, you need to read a number as a command line argument and then give you ten or something like that. Okay? So you don't have to worry about it, but keep it in mind. So those are command line arguments, and again, I'll post this later on. All right. Okay, that's good. What else? Finally, I wanted to show you one more thing here as a miscellaneous item: linters. All right, there we go. Linter. Oh. Oops. Sorry. All right. Well, often your code may be syntactically correct and may compile, but still may have lint. All right. So what is lint? Well, this is, again, computer scientists are not too savvy when it comes to thinking of new words. Why make a new word when you can take an old word and give it a new meaning? So lint, my clothes, right? They could doesn't look like, well, maybe I've got some lint back there, but this shirt is generally clean. It was cleaned, I assure you. But even though your laundry may be clean, you may still have little bits of fabric on it that need to be taken off. We call that lint. So even though your code is clean, it compiles, it might even run, your code may still have little pieces of lint on it. What do you do with lint on a piece of on your suit or whatever? You take a, what do they call them? A lint roller, exactly. A lint roller that is a little roller that's sticky, and you roll it over, and then it takes off all those pieces of lint. A linter in code, with respect to code, is kind of like that lint roller. It warns you about things that looks suspicious. That's syntactically correct, but you probably didn't mean to do that. You might have that might be a bug, right? GCC can be used as a linter, right? There we go. GCC can be used as a linter to detect potential problems, right? These are, again, are potential bugs that are not necessarily syntax errors and may not even be bugs, but nevertheless are pieces of code that you should probably take a second look at. All right? In fact, all the pitfalls that we mentioned, it's now been a week, unfortunately, but all the pitfalls that we previously mentioned of things like, remember, 0 is less than or equal to a, less than or equal to 10, you probably didn't mean that. Even though that was syntactically correct, it compiles, it runs, it gives you bad results. The real solution is to use an and between them. Another common issue is an assignment operator in an if statement. That'll compile, that'll run, it'll give you bad results. Yet another example is using a semicolon where you probably didn't mean to. That'll compile, that'll run, it'll give you bad results. How can we use GCC as a linter to pick out these little pieces of lint and tell us, well, your code is clean, but you probably want to take a lint roller to it and take a second look? The way that we do that is, I'm going to go ahead and go into my account here, because I've got a nice demonstration set up already. Miscellaneous demos. Sorry for the donking. Unix. I don't know if there's a better word for it or not, but that's what the Macs do. All right, they donk. All right. So here's a very simple. This is a do-nothing program. It's syntactically correct, and if I run GCC on this, it's going to say it's clean. Right? But there's a lot of issues here. First of all, there's all those issues that I was mentioning before of a semicolon where you probably didn't mean it, an assignment operator where you probably didn't mean it, and this thing where you probably didn't mean it, as well as a bunch of other things. For example, if you take a real close look at this line, what did I miss? Ampersand. Right? You don't have to take such a close look. Again, if I just go ahead and compile this straight up, it's perfectly fine. Go ahead and run it. But if I compile this with the following flag, WAL or wall, whoa, lots of lint there. Things that, the format, that's one thing that I didn't notice at first. I used the incorrect formatter for an integer. Right? I used the incorrect format I didn't provide the correct number of arguments to printf. It expected an argument of type, this is a little bit different. This is the missing ampersand right here. Warning, suggest parentheses around assignment used as truth value, because that is an assignment operator, not an equals equals. Comparisons like x is less than equal to y, less than equal to z do not have their mathematical meaning. Warning, right? This is one of those things that's actually not lint. I would classify this as cruft instead, and I'll explain that in a second here. Warning, unused variable foo. I created a variable, I never set it, I never used it. What's the point of creating a variable that's unused? That is garbage code. That's code that probably should be eliminated. Right? It's not going to cause a problem to just declare a variable and not use it, but sometimes we call these things code smells. Right? There's nothing wrong with it. It just kind of stinks. You need to clean that up a little bit. Another word for it is cruft. That comes from either Yale or Harvard. I forget which one. But back in the 60s, 70s, or whatever, they had this old. They moved to a new. Their computer science department or whoever they were moved to a new building. You can look this article up on Wikipedia if you want. And the old one was called Cruft Hall. That's C-R-U-F-T. Cruft Hall. It was empty. So because it was empty, people started putting old equipment in it. Right? The overhead projectors that became obsolete, we'll just go ahead and throw them over there. The 50 chairs that are broken, we'll go ahead and throw them over there. And so it just filled up with garbage. And useless garbage that probably should have just been taken to the dump or recycled or whatever. So it became known as cruft because it was Cruft Hall. It was the garbage dump. Code can also have cruft. Cruft is stuff that has no meaning, it's garbage code that's unused. It's garbage code that probably shouldn't be there. Go back and clean it up. Right? Get rid of the cruft. Clean out Cruft Hall, renovate it, and make sure and move somebody else in there. Right? Unfortunately, we don't have the luxury of having a garbage dump building, although some of them should probably be garbage dumps. Right? All right. So that's linters. Again, you can run. It's best practice to always use the WAL flag when compiling with GCC. Practice. There we go. You will catch so many errors immediately up front before it compiles, but it runs, but it doesn't give me what I'm looking for. It's because it gives me a segmentation fault. I forgot that ampersand. By running it with WAL, that WAL flag, it'll catch those things. Yeah. Yes, it's case. I believe so. It's case sensitive. This stands for warnings, all of them. Right? That's what it stands for. The flag itself is just a capital W, and then the word after it is specifying which warnings do you want. I want them all. So sometimes people just call it WAL. WAL it, run GCC with WAL, right? Because that's what it spells. Right? Okay. Any other questions so far? Yeah. Oh, no, so, here first.
If there's no lint or warning, but it's still just like it would look like you just compiled it and just returned.
Yeah, like I did before when I compiled linty without that flag, right? Perfect. Yep, it would just do that, and that's the default. If you go lowercase w, by the way, that shuts them all off. That shuts off everything. No warnings whatsoever. So that's why it's case sensitive. Yeah, go ahead. Oh, okay, all right, good. All right. Let's see, what else did I want to do? All right. Okay, then let's talk a little bit about style. And for that, I'm going to cut and paste and move this over here. There we go. Style. Instead of, and this will be part of your notes here. Let me increase the size just a bit. So we've talked about a lot of this before. This is why I'm not going through it with a fine-tooth comb. And you've also gotten feedback on several of your hacks already of proper variable names, proper styling. The rules for variable names in C are that it can contain any alphanumeric character, A through Z, lowercase, uppercase, 0 through 9, or the underscore. But they may not begin with a number. And that's just that's a historical thing with respect to parsers. If the compiler is looking at all the code and it encounters a number, it's going to assume that it's trying to parse out a number. And so that's why they put in the rule that it can't begin with a number. It's to make writing compilers easier. Right? In general, you should follow a consistent naming convention. If you want to use one naming convention over another, we're not going to fault you for it. There are at least 5 or 6 different major style guides for C. GNU style guide, Chrome style guide, or not Chrome style guide, but Google has their own style guide for C and stuff like that. As long as you're consistent, that's what we're looking for. There are several different naming conventions. For example, underscore casing convention, where you take all of the multiple compound words and then you separate them with underscores. I think I mentioned it before, but I like to dissuade people from doing that, even though that's the classic style. I like to dissuade people from doing that because if you're always typing underscores, what are you doing? Shift and then all the way across the keyboard to get that hyphen for the underscore, shift underscore, pretty soon your pinky is going to fall off. All right? That's why I don't like doing the underscores. If you like doing the underscores, fine, go ahead and adopt that style, but be consistent about it. And then when your pinky finger falls off, then you'll adopt a different naming convention. You also have uppercase underscore casing. Those words are separated by underscores, but all the letters are uppercase. That's usually used with constants. For example, you've seen this already, pi in the math library. Capital M underscore capital P capital I. They're using uppercase underscore casing for that because it represents a constant, right? Or a macro. The more modern convention is the one that I prefer, is to use camel casing, where the first letter of the first word is all lowercase, and then the first letter of each subsequent word is capitalized. It makes it really easy to read there. If I didn't have those capitals in there, I would not know where the demarcation of each one of those words was. It'd make it very, very difficult to read. So by capitalizing it, though, you can read that very easily. It's really easy to read. Variables should have descriptive names. Name them after what they are. X, Y, A, and B are okay if you're describing XY coordinates, because if you write an XY plane, you don't call this, I don't know, cheese and this green, right? You call it X and Y. But they're not okay if they're representing something else. For example, initial value, longitude, latitude, like in your last hack, theta, or angle of incidence, latitude degree, etc. Right? Theta is okay in a mathematical context, but if it's actually describing something like an angle of incidence or an angle of refraction, as in your homework, you probably want to name it those things. Because it's not just a generic old theta 1 and theta 2, right? It actually means something. It actually stands for something. It actually models something. In general, abbreviations or acronyms are okay, but should be minimized and should only be only if they're well understood. APR, most people understand that that's annual percentage rate. SSN, a lot of people understand that that's Social Security number. But I mean, you're not paying by the letter in your code, so you might as well think about writing those out in full. Okay. especially if it's not well understood. NUID might be okay for if you're writing a program on this campus, because everybody here knows that it's your NUID. It's your Nebraska University Identification Number. But if you were writing code for a general populace, nobody knows how we identify people here at this university, right? Over in Iowa, they do it some other way, right? So don't name things. You would actually have to write it out for other people to understand. Code should be self-documenting, meaning that code should express its meaning and intent. That if you took your code and gave it to somebody who was pretty competent in C, they should be able to go and read each line and know what each line does. For example, in our program that we just wrote, I was documenting things so that for presentation purposes, but I didn't put in a comment like this. Declare a variable to hold a decibel value. Right? That's a stupid comment. Right? Bad comment. Right? Why? Because anybody who has reasonable knowledge of C or many programming languages can look at line 8 and see, okay, int, decibel, I know what this is. It's an integer value that represents a decibel value. Right? They don't need that sentence up there. In fact, that sentence is distraction. So code should be self-documenting. If you've got variable names that describe what they stand for, that's self-documenting. If you've got lines like, that's commented out now, but printf and scanf, anybody who knows C is going to know, well, that's printing out this message. You don't have to have yet another line that says, print out a prompt message. Right? That's not a good comment. Yeah. Oh, yeah. Technically, I think GCC only allows up to 256 characters in a variable name. It might only be 255. But certainly if you're getting over 3 words, probably, yeah, think about how to restate that, right? Initial value that I read in from the user. No, that's a terrible variable name, right? Yeah, it's more of an art form at that point, right? You could, if you've got one reasonable variable name and another reasonable variable name, then you guys can go ahead and debate about that. But there are some things that are clearly unreasonable, x and y to represent APR and whatever longitude. And there are clearly things on the other side of the spectrum that are way too long. Variable name, a variable that I read in from the user to treat as a decibel value. A phrase should not be used, right? In general, avoid pluralizations unless it's an array or a collection, which we'll get to later. White space in your code with respect to your stylization is also important. Again, indentation, code blocks should be indented. In that main, it should be indented. If you've got an if statement, it should be indented again. It's just like writing an outline to a paper. If you've got bullet point 1, bullet point 2, bullet point 3, those should all be at the same level. If you've got subpoints and sub-subpoints, each one of those is indented. Right? And that's how you read code. It's kind of a line by line, a bullet pointed kind of thing. And that's why we use indentation. 2 spaces, 3 spaces, a tab, it's all up to you as long as you are consistent about it. In general, compilers don't care about it though. Right? It's just simply a style thing that makes your code more readable to other humans. The compiler doesn't care about any of that stuff. It ignores white space in general. You can use tools. Text editors will format automatically for you. For example, Atom.io, that's an IDE. If you go to the next line, if you hit enter, it'll go to the next line at the same indentation. Right? You can also there's also that. Actually, I don't like that formatter. Let me get rid of that. I'm going to show you a better formatter here. Darn it, where is it? Find format. There we go. I'm going to take this out and give you a better formatter. What was it? It was a C++ formatter. Don't worry that it's a C++ formatter, but there we go. This is the link that's available in Canvas already, by the way. What you can do is you can take your code. Let's take the code from REPL here and say that, OK, inconsistent indentation, right? Cut, paste over here. And there are several different styles that you can conform to. It's probably too small for you to read here, but LLVM, that's a compiler. Google, Chromium, Mozilla, WebKit, those are other style guides. Let's just go ahead and choose one. Let's say Google. I like Google's. So let's format it. It comes back and fixes everything for you. Right? It's best to get into the habit of writing well-formatted code up front. As you've probably already seen in Lab 3, at least it was reported by a couple of learning assistants that a lot of the mistakes some of the mistakes that people were making was because of poor formatting. They couldn't see the forest for the trees because they couldn't read their own code. It was all over the place. They couldn't see where the if statement began and where it ended. So something that they thought was in the if statement was actually outside because they didn't have the proper indentation. Right? Or something that they thought that was outside of the if statement was actually inside the statement because they didn't have proper consistent indentation. You can use a tool like this in the beginning, but again, get into the habit of writing well-formatted code up front. Right? And again, that's available in the in Canvas. Right? Let's see, that's white space. And then there will be some other style items later on when we take a look at more advanced stuff. But for now, I think that that's everything that I wanted to cover as a supplement to the conditionals. All right. Any questions so far? No? All right, then very briefly here, I want to give motivation for next week. We're going to come back and start talking about loops. Let me see. Lectures. Remove. Where is it? I should just put this over here. Loops. Put this in. Copy, paste, and loops, and then I'm going to get rid of this and mark down preview plus. There we go. So open a new window. There we go. And I will increase the size on this. All right. So as a really quick motivating introduction to next week, we've got basic input output. We've got basic variables. We've got basic logic and conditionals already under our belts. What the next control structure that we're going to introduce is loops, ways of repeating things. All right, if you wanted to print out the numbers 1 through 10, you could write 10 print statements, but that's first of all, that's a toy problem anyway. We wouldn't do that. But you could write 10 print statements, print 1, print 2, print 3, but you wouldn't actually do that in a piece of code if that's actually what you wanted to do. Instead, you need a way to repeat a piece of code. Print I for a value I running from 1 up to 10. Right? That one print statement should be repeated 10 times. The way that we do that is by introducing loop control structures. There are 3 basic elements to every loop control structure. Again, if you're going to repeat something, you need a starting point first of all. Think about a loop. If you're going to try, or a track, if you're running around the track, what do you need? Well, you need to get on the track. That's where you start. Then you're running around the track. You repeat 1 lap. You repeat another lap. The second element of that is what you're doing on that lap. You're running. The third element is well, you can't run forever, can you? Say 9 laps is a mile, right? Just like the rec center, is that 9 laps? The second floor, right? 9 laps to a mile, or 3 laps if you go in the Cook Pavilion, 2.5 or something. So you run around. Well, you're not going to run forever. You just want to run for a mile. So you want to run 9 laps. 1, 2, 3, 4, 5, 6, 7, 8, 9. How do you know when to get off the track? You need an exit strategy. You need an exit condition. Right? So that's basically where these 3 pieces come into any loop. You have to have an initialization, a starting point. You have to have a continuation condition. While I've not reached 9 laps, continue running. Right? How long should the loop continue? When should it stop? Those are the same things. A continuation condition says keep going. A termination condition says stop, terminate the procedure and move on. Right? And then, of course, you need to be making progress towards that. If I counted my laps here on my right hand, and I ran a lap, And I left all my fingers down here. Still 0 laps. Run another lap. Still 0 laps. Right? Run another lap. Still 0 laps. What am I going to end up doing? Yeah, running forever. I don't think I could do that. But eventually I will collapse, right? But you'll get stuck in an infinite loop if you look at it from the perspective of code. So what you need is an increment or an update. You need to make progress towards that termination condition. I need to keep track of how many laps I've run. 1 lap, 2 laps, 3 laps, right? And each time I reach my starting point again, I say, have I run 9 laps yet? And if I have, that's my termination condition. If I haven't, that's my continuation condition to keep going, right? So the first type of loop that we're going to look at is a for loop, and I'll give you the basic syntax here to identify these 3 things, and then that's where we'll leave it for the week. A for loop uses the keyword, what do you think? For, exactly. And identifies the 3 elements on the same line. I'm just going to go ahead and start with a simple example. We'll go ahead, instead of counting to 9, we'll go ahead and count up to 10. For int I equals 0, let's go 1. I is less than or equal to 10, I plus plus. Right? And we'll go ahead and printf lap %d and the line I. There we go. That's a nice little piece of code right there. I'm going to go ahead and run it in, say, REPL, and let's see its output. So I don't want to take out the main, but I want to take out everything else. All right, there we go. Let's put in my for loop here. I'm crossing my fingers that this will work. Okay, excellent, it works. They're using some, I'll show you this later. I'll show you something later. This will not work on CSE. I'll show you how to get it to work. So lap 1, lap 2, lap 3, all the way up to lap 10. Right? I'm running 10 laps, so I'm running 1.1 miles or something, 1.11 miles. That's my goal for the day. Right? The 3 elements are all on the same line. The initialization, where is that? I start I at 1. That's the initialization right there. The continuation condition. While I is less than or equal to 10, keep going. Run another lap, right? Print that lap and then go back up to the top. Repeat this loop over and over and over again. And then the third element, the increment, you have to make progress towards your termination condition. This is new syntax here. I++ adds 1 to the value I. We could rewrite this as I plus equals 1, or so I is equal to I plus 1. And that would make sense to you, right? I take the value in I, add 1 to it, and then put it back into the same variable I. But it happens so often that they made a shortcut for it in most programming languages. That is a postfix increment operator if you want the technical name for it. Don't worry about the technical name. Just understand that it increments that variable by 1. It adds 1 to that variable. So on the first iteration here, we've got that the I has a value of 1. So it prints out lap 1. Then it checks, is I less than or equal to 10? Well, it's 1, so yes. Let's go ahead and execute this. Then at the end of the loop, it increments it by 1, so it goes up to 2. Prints it out again. It's still less than 10. So it goes ahead and adds another one, 3, 4, 5, 6, 7, 8, 9, 10. Then what happens? Once it's 10, it's still less than or equal to 10, so it prints out lap 10. Right? At the end of the loop, it increments it to what? 11. And I don't have enough fingers to do that anymore. Right? 11 is not less than or equal to 10. So what happens? The loop terminates and exits. Once you've run your 10 laps, then you're done. Right? And that's the basic anatomy of a for loop. All 3 of those things, the starting condition, initialization, the continuation condition, and the increment towards that termination condition is all on the same line. We'll look at the details next week. In particular, the first 2 have semicolons. The third one does not. You put you have parentheses. You have opening and closing curly brackets. And for this example, I created the variable I within this loop. This is called a loop scoped index variable. We'll talk more about that later on. But yeah, go ahead. It increments at the end of the loop, and then it checks at the beginning of the loop. Should I continue executing? Right? That's the order. Otherwise, if it did it the other way, continue and then increment, we would probably get that 11, right? Or if we change this, right? If it's strictly less than 10, now what? It's going to print lap 1 through lap 9, right? Or, I don't know, do 100 laps for the weekend. Right? Any questions? Oh, yeah, go ahead.
So you said that this wouldn't run on the CSE.
Oh, okay, so do you want to see that? I guess we've got a few minutes here. I'll show you why it doesn't run on CSE. Emacs, loopy, let's see. All right, there we go. It won't compile on CSE. GCC, loopy, there we go. It's complaining about that loop scoped variable. The for loop initial declarations are only allowed in C99. Back in the 80s, C89, when it was 80s and throughout the 90s, you couldn't put int I within that loop. You see that very commonly in most programming languages. They updated it in 1999 to allow it. So if you want that on CSE, then you need to use std GNU 99. Right? And now it's OK with it. All that is saying use a different standard. Use the GNU 1999 standard and allow this. This and one other thing in the entire course are the only things that are different between those two. You can certainly go with old school C and not declare it right here. Declare it right here. Oops, int I. And now this will work in any standard. Right? But that's a technicality that we'll cover later on. Right? It would still evaluate at the end. I don't cover the prefix increment operator because it's some people prefer it as a matter of course, but I want to keep things simple. We have one. Why have two things when you can have just one? And we'll focus on that. Yeah.
Do it line 6 int I equals 1 to line 7 for I semicolon.
Say that again.
Int I equals 6 there, and then in the full loop, I semicolon equals 1.
Oh, well, here, yeah. You could have empty elements like that, yes. But I won't cover that either. Keep it simple, right? KISS, keep it simple, stupid. So we're not going to cover all of the little tiny things that C supports, but you can certainly experiment on your own, right? All right, have a good weekend. What's the spread? Oh, nobody knows. All right. You need to report at least as many. At least as many as you expect off of, yeah. Yeah, you can. It all depends on you use that formatting tag. Right. Well, you still need to push it to your read. You're going to turn in the URL, not the what if I don't have like oh, you probably want to. No, because there's a lot of like. Yeah, you redo it so that we can see those commits. Yeah. I mean, don't throw away everything that you did, right? Save a copy over here. Delete the repo and restart it, and then you don't have to restart it. Yeah. It'll be on a third.
I think it's a Wednesday we get back.
It's a Wednesday. Okay.